Hi and welcome to Chandu.org. In this video, let's talk about the process of creating a panel chart in Excel and compare that with how we can create a similar chart using R. I have been learning R programming for the last 6 months off and on, and I'm always fascinated by all the possibilities that these new, well, R is not a new language but new for me, open up. But because for most of my work in my business I use Excel, I'm gravitated towards Excel, Power BI and Power Query and other tools whenever I'm wrangling with data. But recently at work I came up with a situation where I found that the solution for the problem is uh, far easy when I use R compared to doing it in Excel. So let me just uh, back up here and quickly explain what's going on. Uh, as you know, I am doing some consulting work for a large government ministry in New Zealand, Wellington, and I work in the HR department. And the the usual norm in New Zealand is all the remuneration reviews and performance reviews and ratings are done in the month of June and July, and then once all the ratings are finalized, then employees will be awarded some extra salary hike or bonus or performance bonus, etc. So we were looking at some data sets from the recent REM cycle, and I was asked to produce some graphs explaining the rating distribution by individual branches. There are different groups, business groups, and each group has several branches. Uh, and across the ministry, there would be a distribution that is desirable. This is called as curve and distribution curve. And you don't want, like, it is not even possible to have everyone outstanding performer or everyone at the lower end of the spectrum. People usually gravitate towards the middle with some exceptions on both ends, just like the typical normal distribution. And I was looking at some data. This is not the real data. I made up the data here in Excel. Let's say we are looking at some data where we have an employee, their group and branch information, along with some rating data, like what kind of rating they received and how much salary hike they received. There are 5 possible ratings, starting with NME. NME stands for not meeting expectations. This is the lowest rating that you could get. AME, achieved most expectations, and SP stands for successful performance, OP for outstanding performance, and NR for not rated. This is usually if you are hired in the month of May or June, then you wouldn't qualify for the REM review that happens immediately. Likewise, if you are a special type of an employee, like I'm a contractor and I don't really have any REM review happening for me, it's usually only for the permanent employees. Other kind of fleeting employees would not qualify for this. So 5 kind of ratings, and you really want to see uh, what percentage of staff are in each of those brackets. And if the answer is simply show me how many people are there, I could make a pivot by group and branch, and then show the number of ratings like this. I could show the percentage or the actual numbers. Well, you show the actual number and then you right click and use show value as row total to see what percentage of each group branch combination had what kind of ratings. This is all fine, but the picture that the senior management wants to look at is more like a graph that shows what kind of curve each branch is following. So a quick option would be we could go and select all these numbers and insert a panel chart, a spark line into a location that is adjacent. So you can see the distribution by individual office, and they'll tell you if you want to highlight the non-rated employees, you can use the NR and set up that as a different color, and and probably the last point color in gray. So there you go, a really simple chart. But what we wanted to produce was not a sparkline, because this is a vertical reading, it is not possible. We wanted to produce something that is more like a panel chart, where multiple charts are there, all of them showing similar data set but grouped by different things, and then they fit into one screen. So here is something that we were trying to achieve. Now there are 80 branches in this sample set data set. In my work there were not 80 branches, because we had to make these reports by individual groups, so there were significantly fewer, and but it is still a lot of work, right? If you are making regular charts, not the sparklines, then you couldn't really use the select data and insert sparkline thing. You had to actually make a chart, and this being a pivot table, it's not easy. Like if I select only this much and I want to make a chart from that, I insert a column chart. Excel thinks, oh, you're making a chart from pivot table, let me be helpful, and it creates a chart for everything that is in the pivot table, creating a mind-numbing chart for us. So this is not good. So what I had to do was, after pivoting, we had to create a chart that somehow cheats Excel. But let's talk into that thing. So for example, I could insert a column chart, then go to select data and add manually the series, in values will be those those values. So there is a chart, and their labels would be those 5. So we get something like this. That is the first chart. We then do any bit of tidying up that needs to be done, like probably making it like that and making axis 0, and then copy paste this chart, rearrange the data source, and then repeat several times. After all the 80 charts are created, we then have to arrange them in a grid fashion, which is also a lot of work. So this is where I got frustrated, but because I am well versed in Excel, I quickly realized what I'm doing here, and I wrote a small macro that can do the job for me. That is, I create one chart and then I tell the macro where my range is, and it would just copy and drag down the formula ranges for each of those series formulas on the top, and adjust the chart and create all of them. Once those are created, I rearranged them into a grid fashion. But all of this is too much work, right? And I keep thinking, Microsoft is adding more and more charts into Excel. We are using 2010 Excel at work, but it doesn't matter. Like 2016 Excel that I'm using for recording this has got these heaps of new charts, right? Like the waterfall chart and the tree map and sunburst. I think it's time Microsoft thinks a little bit and probably gives us a panel chart option, where you create one chart and then tell Microsoft, hey, can you make a panel from this using this data set? And maybe the smart folks in Microsoft can do that for us. Of course, I understand a lot of various other things, like once you create the chart, you select it and you can format and others. So all of these have to be thought through, but that would be good. So now if you're wondering, hey, this is all looking good, but how did you create that? Well, what I did is I cheated. I actually created sparklines because I was too lazy to make 80 charts and I don't want to use VBA. So I made a sparkline. I'm going to show you some techniques. So if you have a sparkline in a cell, let's say we have 1, 2, 3, and 4. In a blank cell, if you insert a sparkline with the data, it comes here, right? But if you rearrange the cell, the sparkline grows because it is attached to the cell. But if you look at the cell itself is empty. So you can actually put a title here, like I can say HR ratings as my title. So that shows up there too. I can use the cell alignment to align that so that it looks like a regular chart. And using the next cell, I can add my label as well. I can say NME AME, SP, OP, those are the ratings, but the ratings would only show up like that. So we can, no matter what you arrange, they won't align with the chart. So once you have the title there, you can use Control 1 to format the cell, go to horizontal alignment options, and just use the distributed option. This will distribute those 4 labels so that they fit into the cell, and that's how it looks more or less good enough. That's how one. So how did we do this entire thing? Well, it's very simple. I created the 80 sparklines as a group here, and then I moved them into this page, painfully rearranged them 8 at a time into 10 columns. I think that's what it is. And then applied cell borders and used some little bit of index formula to get the group name and branch name to show up as a title, and top aligned them and added labels in the top and bottom. It's a little bit of work. It probably took me like 20 minutes, and because this is the second time I'm doing, I'm a little bit more productive. But I want to show you how ridiculously easy this is to achieve with very little bit of R programming. So here is the R script. I'll provide a link to this in the description of the video as well as on the blog. I'm not a really proficient R programmer. I'm learning, as I said, but it is a really fun language and an interesting paradigm to learn. So what we have here is we are going to use the tidyverse library, which has all these packages for creating charts and manipulating data and all sorts of cool things. And it kind of reduces most of the work that you need to be doing. Think of this as a reference in your VBA code. So the first thing is we read the data. If you're using your own local file, then you could just import the data set. By the way, this is RStudio, again a free software that you can install when you install R, and that kind of gives you this IDE environment where you can type your R code. So you can import your data set, and that will come up here as a variable which you can refer to. But because this is a standalone piece of code, we are assuming I'm going to read the CSV from that web link. I haven't really tested this from web, but those are the 3 lines. So let's get started. We will run these 3, select those 3, and press Control Enter to send them to console, where your computer will load the data. So you can see the REM data set is loaded. This is exactly same data as what we have seen in the Excel file, except this is saved as a CSV file, so it is loaded into R. So the same columns are there. Now what we want to do is we want to make a pivot table format from that before we create the charts. You don't necessarily need to do that, but I feel comfortable creating the remuneration pivot. And this is basically generated from that. I'm using the pipe notation from the tidyverse. If you're not familiar with it, you could imagine doing this by a bunch of variables as well, or different steps. So we take the REM data, we group it by group, branch, and rating, right? That gives us a group data, and then we summarize it with 2 columns. One is count and the other is spend. Count is number of rows in each of those combinations, and spend is nothing but how much money we are spending. If you look at the REM data, we have rating and hike, so we are counting how many ratings are there and what is the total count. That's what we are doing. And then we pass that data set to another group where we just count by group and branch, and we find out what is the total values within the branch. So I'm calling that as a B count variable by adding that as a column through mutation, and that's nothing but sum of counts. And then we add the grouping, one more layer of grouping, the rating thing back, so using the add thing, and then we mutate so that we can calculate the percentage. This is because there is no direct way to calculate percentage in the summarized thing. You can only count and sum and mean and standard deviate, etc. So we go one level up and then find the total count, and then come back into the lower level to divide that to get the percentage. So at the end of this process, we will end up with a new data frame called rem pivot, which is exactly like our pivot table. So I'll just press Control Enter to that. This creates the rem pivot, which is almost similar to our pivot table. I say almost because if you look at our pivot table, it only has group, branch, and then ratings along the top, the percentages here. So it only shows the percentages and the ratings are there. But you could imagine the same pivot where if the ratings were in row labels level, the percentage values as a column. That's what it is. It omits the counts and the sums, but I'm calculating them in R so that I could probably use them for other kind of charting. Going back to our code, now that the pivot is calculated, all we have to do is use a ggplot on the rem pivot, and we create a bar chart where on x axis we show the ratings, on y axis we show the percentages as identity, because that means the percentage is already there, just plot it as it is. And if you just do that, then it is going to show the labels in alphabetical order in AME, NME, and R, like that. And we want the ratings to be in this order because that's the logical order. So I'm setting a discrete limit on the ratings x-axis, and using the facet wrap, which is basically saying give me a panel chart. That's all it is. And using this to adjust the font size, I'll press enter. This is the one that takes some time, not a lot of time, probably like 10-15 seconds. I'm recording this, so it might take a few more minutes, but when you see this stop light going away, that's when the plot is generated. It would come up somewhere here. There you go. The plot is here. I mean, it is too busy, but if you zoom, you should be able to see the whole thing nice and clear. So there is your panel chart that shows the entire information in one go. So you can see, you can create this. It is just a bar chart but multiplied using the thing. And the advantage of this is it kind of shows consistent axis, and everything is there. Labels are properly there, titles are there, everything can be styled, and it's simply awesome. So once you know how to do this, you could potentially create any other kind of panel charts very easily and quickly using R. Whereas in Excel, to do them, for example, if I want to create a panel chart, but this time not bar chart or line chart, I want to show dot plot or something else, there is almost no way we can do this. I mean, the only way we would be able to do this is by manually creating the charts and laying them out and manually adjusting each and every chart's x-axis minimum, x-axis maximum, and God knows what else, maybe y-axis parameters too, and carefully positioning, adjusting the plot areas and chart area sizes and all that. And it is just too painful and too vulnerable, right? If you change any little thing in one of the charts, then all hell breaks loose, because one of the axes is no longer aligned and it kind of creates a distorted view. So I find that at least having these kind of tools in your kitchen sink, like a little bit of R programming knowledge, and being an open source system, I find that more and more organizations are open to installing software like R on everyone's computer, because then people can go ahead and play with data and create some models or visualizations, or do some basic data science fairly quickly. So if you find that R is installed in your work computer, then go ahead and give this a try. Otherwise, ask your boss or ask your IT department, can we get R on this? Or if you have Power BI, you can run R scripts there and show these kind of charts on your Power BI reports as well. So there you go. I hope you find this interesting. I'm not planning to pivot suddenly into R blog or anything. It's just that I find R to be a fascinating language to learn and play with, and hopefully if I am coming up with any other interesting solutions for day-to-day problems, I'll blog about them on chandu.org and post a video if possible. So watch out, and thank you so much for watching this video, and and see you again. Bye bye.